Gore-Tex is W.L. Gore and Associates' trade name for waterproof, breathable fabric membrane. It was invented in 1969. Gore-Tex blocks liquid water while allowing water vapor to pass through and is designed to be a lightweight, waterproof fabric for all weather use. It is composed of expanded PTFE, EPTFE, a stretched-out form of the PFAS compound polytetrafluoroethylene, PTFE. In 1969, Robert Bob Gore stretched heated rods of polytetrafluoroethylene, PTFE, and created expanded polytetrafluoroethylene, EPTFE. His discovery of the right conditions for stretching PTFE was a happy accident, born partly of frustration. Instead of slowly stretching the heated material, he applied a sudden, accelerating yank. The solid PTFE unexpectedly stretched about 800%. Forming a microporous structure that was about 70% air. It was introduced to the public under the trademark Gore-Tex. EPTFE has a porous microstructure composed of long, narrow fibrils that intersect at nodes. Increasing the processing temperature or increasing the strain rate leads to more homogeneous expansion with more spherically symmetric pores and more intersections between fibrils. The formation of EPTFE is enabled by the unwinding of PTFE molecules to create large pores within the structure. This favors highly ordered crystalline PTFE that allows the molecules to disentangle more easily and uniformly when stretched. The porosity is largely determined by the stretching temperature and rate. Changing the stretching rate from 4.8 m per minute to 8 m per minute can increase the porosity from 60.4% to 70.8%. Due to the high work hardening rate of PTFE, EPTFE is significantly stronger than the unstretched material. On a microscopic level, this work hardening corresponds to the increasing crystallinity of PTFE as the fibrils untangle and orient upon the application of an external stress. EPTFE has a strikingly high ultimate tensile strength of 50 to 800 megapascals relative to its full density counterpart of 20 to 30 megapascals as a result of its high crystallinity. This behavior also yields a negative Poisson's ratio due to the expansion of EPTFE along all directions, contrasting the more expected reduction in the directions perpendicular to the stress in cases with volume conservation. EPTFE has tunable porosity based on the processing conditions and can be made permeable to certain vapors and gases. However, it is impermeable to most liquids, including water, a property that is exploited in certain applications such as raincoats. These additional properties, in combination with the inherent properties of PTFE-based materials, more generally make EPTFE a versatile material for a range of applications. Gore-Tex materials are typically based on thermomechanically expanded PTFE and other fluoropolymer products. They are used in a wide variety of applications such as high-performance fabrics, medical implants, filter media, insulation for wires and cables, gaskets, and sealants. However, Gore-Tex fabric is best known for its use in protective, yet breathable rainwear. Before the introduction of Gore-Tex, the simplest sort of rainwear would consist of a two-layer sandwich, where the outer layer would typically be woven nylon or polyester to provide strength. The inner one would be polyurethane to provide water resistance at the cost of breathability. Early Gore-Tex fabric replaced the inner layer of non-breathable PU with a thin, porous, fluoropolymer membrane coating that is bonded to a fabric. This membrane had about 9 billion pores per square inch. Each pore is approximately 1/20,000th the size of a water droplet, making it impenetrable to liquid water while still allowing water vapor molecules to pass through. The outer layer of Gore-Tex fabric is coated on the outside with a durable water repellent treatment. The DWR prevents the main outer layer from becoming wet, which would reduce the breathability of the whole fabric. However, the DWR is not responsible for the jacket being waterproof. Without the DWR, the Gore-Tex layer would become soaked, thus preventing any breathability, and the wearer's sweat would fail to evaporate, leading to dampness there. This might give the appearance that the fabric is leaking when it is not. Wear and cleaning will reduce the performance of Gore-Tex fabric by wearing away this durable water repellent treatment. The DWR can be reinvigorated by tumble drying the garment or ironing on a low setting. Gore-Tex is also used internally in medical applications because it is nearly inert inside the body. Specifically, expanded polytetrafluoroethylene, EPTFE, can take the form of a fabric-like mesh. Implementing and applying the mesh form in the medical field is a promising type of technological material feature. In addition, the porosity of Gore-Tex permits the body's own tissue to grow through the material. integrating grafted material into the circulation system. Gore-Tex is used in a wide variety of medical applications, including sutures, vascular grafts, heart patches, and synthetic knee ligaments, which have saved thousands of lives. In the form of expanded polytetrafluoroethylene, EPTFE, Gore-Tex has been shown to be a reliable synthetic, medical material in treating patients with nasal dorsal interruptions. In more recent observations, expanded polytetrafluoroethylene, EPTFE, has recently been used as membrane implants for glaucoma surgery.